In Creo Parametric 10.0, there is a new kind of formula-driven lattice called IWP. Here you can see an example of it on the screen. Let me rotate so you can see some more of what it looks like. And from the different angles, you can see that there's a lot of available empty internal volume in this structure, but it is continuous and extremely strong. Let me change to another window where you can see just a single cell of what this structure looks like. And before I show you how to create it, I'm going to jump over to some slides in order to explain what this IWP shape is. So this IWP lattice type is a new formula-driven lattice that is available in Creo Parametric 10.0. And this shape was discovered by someone named Alan Schoen in 1970 as part of a paper that he wrote for NASA. And it is something called a triply periodic minimal surface. And with minimal surface, that's a surface that is going to localize the minimum area. And as a result of minimizing the area of the surface, it is going to have zero mean curvature. And there are some other kinds of minimal surfaces. For example, a plane, a simple plane, is a minimal surface in itself. Another one is something called a helicoid. I'm not going to show anything about a helicoid in this video, but just a hint. And so with this triply periodic minimal surface, there are other different kinds of structures, and I'm going to mention three of them, and you'll see this in a moment. The other kinds of triply periodic minimal surfaces include shapes such as a gyroid, the Schwartz P shape, where the P stands for primitive, and also the Schwartz D shape, where the D is for diamond. And if you'd like to find out more about minimal surfaces, there's a guy who has an entire blog about minimal surfaces, and the URL for the IWP type is at the bottom of the page. I recommend that you check it out. There's a lot of neat information there. And so with this IWP, the reason that it gets that name is because this shape is based on two different kinds of skeletal graphs, and one is the I graph, and the other one is the wrapped package graph. And the way that it is described on the Minimal Surfaces blog, I'm just going to repeat the line here because it kind of explains it in a great way. It is a sphere extending handles towards the vertices of a cube. And if you take a look on the right-hand side at the bottom, that image where I generated that single cell, you can sort of see how it is that sphere with the different handles going towards the 8 vertices of a box. And the use case for this, it is great for heat exchangers because you're going to get incredible structural integrity plus a lot of available empty internal volume. Before we jump back into Creo Parametric, let's take a moment to thank today's sponsor.
This video is brought to you by Arena, a PTC business. Arena is the proven market leader in cloud product lifecycle management with over 1,300 customers worldwide. They're focused on helping manufacturers move away from spreadsheets and other manual, disconnected systems to accelerate innovation. Keeping your internal teams and external partners aligned throughout new product development is essential to avoiding costly design errors and product delays. By bringing together bills of material and the entire product record in a single system, Arena PLM enables everyone to collaborate in real time on the latest designs and reduce engineering change order cycle times. Your mechanical, electrical, and software engineers can address design for manufacturability and interoperability with downstream stakeholders and supply chain partners early in the development process. This minimizes BOM risks and helps release products faster. Visit the link here to learn more about how Arena can help speed engineering design efficiency with one connected system. Now back to our video.
Here I have a different part. It is a simple box. It is just a square that is extruded. So to create a new lattice, you will go to the Engineering Overflow menu. Here is the lattice command. And then from the lattice type, we have a bunch of different choices here. And as I mentioned, this is a formula-driven lattice. So I will change to that option. While I have the lattice region tab open, let me choose to replace a body with a lattice. And it automatically selected the only body that is in the model. I'm not going to change anything regarding position and orientation or create a shell around it. I want you to be able to see the structure. But let's go over to the cell type tab, and from the function drop-down list, we have 4 different choices. And you'll notice the first 3 choices are that gyroid, primitive, and diamond, which are other kinds of triply periodic minimum surfaces. And then we have the new type, which is that IWP. So I will select that. And you can see a preview of what the shape looks like. Let me move my mouse away from there. I'm going to go to the cell fill tab for a moment. I'm going to reduce the size of this. Let's make it 0.5, just so that you can see more of the shape and the interior volume. And then I'll go back to the cell type tab. We have our different sizes that are available in here. I will accept the default values, but I do want to show that you can change the values. For example, if I change this to a value of 30, it's going to stretch out in that direction. Let's change the Y value to a smaller value of 10, and this is going to end up scrunching it down. Looks kind of odd, but let's change this back. Let's make this a value of 20 and make this one a value of 20 as well. And I'm happy with those different choices, so I will hit the check mark. Now it is going to take a few moments in order to create the geometry. All right, it took a few seconds to crank that out. Let me zoom out a little bit so that you can see this regular structure. And so that triply periodic, it's repeating in the X, Y, and Z directions. And let me rotate around. You can see from a top view, and as you have these nice little spaces that go all the way through the model. Great for having your different fluids move through here. And so that is your new IWP lattice type. One last thing to mention, let me select the lattice and choose Edit Definition. And if you go to the Density tab, there are 3 different choices in here. You can do uniform variability or variability based on references. And one thing that was added for beam-based lattices a few versions ago was to have the variation in the lattice density to be based off of a simulation. This option is now available for formula-driven lattices in Creo Parametric 10.0 as well. So just one thing to be aware of.